3D printing has gained tremendous popularity in recent years, with many applications in, for example, aerospace and medical industry. These applications require consistent high quality. One technique for 3D printing of metal parts is selective laser melting, where a part is constructed layer per layer by melting metal powder with a powerful laser beam. While this technique is relatively mature, defects such as cracking and porosity are still observed. The laser moves very fast, defects are very small, and defect formation occurs irregularly. This makes reliable in-process quality monitoring challenging. The combination of high-speed monitoring and artificial intelligence can deal with these challenges. Flanders Make has cooperated with different research labs, UGent IPI IMEC, U Antwerpen Vision Lab IMEC, to develop an AI-based high-speed monitoring system for additive manufacturing defects detection. A photodiode and a high-speed camera were installed to track the laser at 20,000 images per second and to monitor the melting process. A calibration object is printed and afterwards analyzed by computed tomography to assess the local quality of the part. This quality information is processed automatically and used as ground truth labels to train a neural network model. This approach enables real-time processing of the high-speed monitoring data, allowing to predict anomalies fast and reliably. A distributed learning system is able to continuously update the AI model to compensate for slow changes. By using artificial intelligence, the 3D manufacturing process can be monitored in real time and control actions can be taken during production to deliver consistent, high-quality parts.